configuration shown here is the control cabinet variant of the system, consisting the inverter, DressView SSE and DressView OT, which are connected via special IP54 certified cable, and spindle for the grinding operation with an external diameter of 62 mm with 1.4 kW power is driven here. The spindle is connected to the screw terminals of the SFU 0300 with a supplied cable. A short sub-D cable connects it to the DressView SSE. The I/O signals from the frequency inverter are also looped through the second 15-pin sub-D and can be used here. The DressView operation terminal, also named DressView OT, is now simply connected to the DressView SSE via the special IP54 certified cable. This cable is used to supply the device with power, and all data signals are transmitted via this cable. The inverter is now supplied with 230/150 volt AC via the connection terminals and switches on. Now we can connect the DressView to 24 volt DC, which is now also booting up. The system is set up in such a way that it boots into this display by default immediately after power on. The load on the spindle using highly complex algorithm is graphically displayed here. After starting the spindle, this value increases sharply and now shows the friction of the bearings in uncalibrated condition as an absolute value. If you press the select key, this value is calibrated to null. This can also be used to hide the effects of a hard coolant jet, for example. If the spindle is now stressed, this value increases visibly. This zeroing can also be triggered via digital input. In order to allow the system to work automatically, two thresholds limit values are available, which can be moved up and down using the arrow keys. You can switch between the two values with the double arrow key. If the load value exceeds these thresholds, corresponding signals are output at the interface. The lower threshold value is the trigger level used to detect the first contact. The upper of the two thresholds is the working level. In contrast to the trigger level, this toggles when the value is above or below the trigger level. It has the ability to transmit surface irregularities to the higher level controller. A pause and storage function is available for use in the laboratory or when setting up a machining center. Press enter and stop to pause the display, and you can examine the load curves at rest. If you want to save this course for a comparison measurement, press enter and select, and a shadow image is generated from the current course. This is possible even if the display has not been paused before. Furthermore, you can see in the middle whether the system is calibrated. This must be done after every change in speed, a start or a change in the ambient conditions. Next to it, you can see whether the spindle is turning, braking, accelerating, or standing. Above the graphics area, you can still find the load display. Finally, on the top right, you see the set rotational speed. This can be set up as well as any other settings in the following menu. To do this, press Menu. In this menu, you will find the currently set speed on the top. To change it, you only need the right side of the keys. The blue cursors below the 1000 digit marks the digit, which you can be increased or decreased by pressing the plus or the minus key. To select the position, you can use the double arrow key to toggle between the 1000, the 10,000 and the 100 digits. Pressing start or exiting this window takes over the newly set rotational speed and sets it to the inverter. In addition, the spindle also starts with start. With stop, it will be stopped again. The display mode indicates how the load value is displayed. In continuous mode, the value is plotted continuously. In block mode, the value starts always at the left position and restarts there as soon as it reaches the right display border. In the controlled mode, the display is similar to that of block mode, with the difference that the display is started as soon as a start signal is detected at the digital input and restarted with a new start signal. If alternating mode is selected, the display plot direction is reversed with every start signal. In the display mode in block and controlled, it is possible to display shadow images which represent the latest progress via the display. With every new value, the last of the 3 shadow images will be deleted. The next step is to set the duration of time required for the load value to run across the display. In the point below, you can adjust the scaling or zoom factor. 1 corresponds to 1 to 100%. 2 corresponds to 1 to 50%, and so on. If set to zoom 10%, the lower display range, 1 to 10%, is expanded to approx. 2/3 of the total range and the remaining third is used for the range 20 to 50%. This allows for very fine resolution at the bottom and the smallest signals to be detected, but still has a good view of the upper range. The crash level is a third threshold limit value, which is not shown in the dressing window. This allows to detect and output a crash that is very close to the working load. Let's now switch to the parent main menu. In the main menu, we see the firmware version of the DressView and the converter, as well as all function menus. The topmost is the terminal that allows normal operation of the inverter, followed by the characteristic curve menu, in which all the curves stored in the inverter can be read and selected in plain text. Then the dressing menu, in which we were just now, followed by the debug menu, in which status and error messages are displayed, and finally the setting menu, in which, for example, the language can be changed or software updates can be executed.